Okay, good morning all. We will be continuing with the next set of examples related to the influence line diagrams. Okay, ILD. So we have taken or we have seen last class with a single point load. We will take up numericals now wherein there are 2 point loads. Okay, I'll just, there are people waiting. Okay. Determine the reactions RA and RB. Okay, shear force and bending moment, right? Shear force and bending moment at a point C. At a point C, when it is subjected to loads as shown in the figure. Okay, subjected to loads as shown, or as shown in the figure, or as shown. So we have to find the reaction, shear force, bending moment at a point C, which is given in the question, right? It is not the general RARB. So the beam is like this. The beam is loaded with 2 point loadings, right? So 1 and 2, and they have shown this as point C, okay? And this distance is given as 7 meters, right? This distance is 6 meters, and this remaining distance is 13 meters. No, not 13, sorry. This total is 20. So what is this remaining? 20 minus 13, that is 7 meters. Okay, and the loadings are, this is 200 kilonewton and this fellow is 100 kilonewton. So for this, at point C, we have to find the reactions and shear force and bending moment using the IID. So the distance between them usually will be usually called as Y. Okay. Is the diagram visible to all of you?
Yes, ma'am.
Yes, ma'am.
Okay. Yeah. We will same as we did for single point load. We'll go ahead with the same concept. If you have missed class that time or if you've not understood, also it's fine. You just listen carefully now. Okay. Now what we will do, even if there are 2 point loads, when we had a single point load also, we used to apply 1 kilonewton at the point where I wanted to find the reaction and solve. So we will do the same thing, applying 1 kilonewton, that is one unit load at point C. Something like this. I will apply, this is your beam, and I'll apply unit load here. Okay, so unit load means 1. So this is 20-meter span. And at what distance? Now I will be keeping the span constant as 20, and this distance I will call it as x now. Okay, so this is your point C, and I will say that this unit load is acting at a point C, which is at a distance x. I know in the reality on the beam it is 7 meters, but now I will take it as x and I will find the value. So this is your point A, this is your point B. We will apply at point C what they have asked us at point C. So at point C, I will apply 1 Newton load or 1 kilonewton load. I'll call this distance as x. This is 20 only, right? Now in this, I have to get the value of RA and RB. I have to write the equation for RA and RB. So if I want to get the equation for RA, RB, I have to use summation M equal to 0. So first time I'll say summation MB equal to 0. Take moment of all the forces about point B. So when I'm taking moment at B equal to 0 of all the forces, RA into 20 will be positive. 1 into this distance. What is this distance? This is going to be 20 minus x. Correct? 1 into 20 minus x is equal to 0 is your equation. So write RA into 20, RA into 20 goes clockwise, minus 1 into 20 minus x is equal to 0. Correct? From here, I have 20 RA is equal to 20 minus x. Or what happens to RA? RA is 20 minus x divided by 20. This is the same procedure that we have done for single point load also, your 1 point load system. So I know now RA in terms of x. What we will do here now, I want the value to draw the IID at what points? I want it at this point, at this point and at this. And I know the distances. Here x is equal to 0, right? Or on the figure if I want to show. Here I'll substitute x as equal to 0. At this point x is substituted as 7. At the third point x is equal to, total distance is how much now? 13. And here x is equal to 20. So we will be substituting these various values of x in the array equation and getting the values of the array, right? So here at x equal to 0, at x equal to 7, at x equal to, total from here to here I'll be looking 13, and at x equal to 20, we have to find the various values of arrays. Tell me please, calculate and get me the values. So here, when x is 0, 20 minus 0 divided by 20 means array becomes equal to 1.
1.
Correct? Next, 20 minus 7 is 13. 13 divided by 20. How much?
0.65.
0.65. Okay. Then 20 minus 13 is 7. 7 divided by 20?
0.35.
0.35.
0.35. And then we have 20 minus 20 0. So directly 0. Right? Now these, what I have got, these are my values for drawing the influence line diagram. So how the diagram is going to look? This is your beam. This is x equal to 0. Under this point, x equal to 7. Here somewhere x equal to 13. And this is x equal to 20. Correct? So at x equal to 0, RA value is 1. And at this it is 0. It has gone like this. And these lines what I'm having now, this is 0.65 and this is 0.35. Okay. So this is your influence line diagram that you're going to draw. IID, you will write it as IID for RA. Right? Influence line diagram for RA. Once this is done, then how do I get the reaction value RA? Last class we had done. If you want to get the reaction value RA, it is the sum of what? The load into the ordinates. Correct? Ordinate means from your influence line diagram, whatever this y value you are getting now, this y value has to be multiplied to your external loading that is present. So the equation is simple. That is, it is going to be load into the ordinate value of IID. Ordinate of IID. So now if I want to calculate RA with respect to point C, or overall RA if I want to calculate only the reaction for overall, then it is going to be, I have 100 kilonewton force acting over here and the ordinate here is 0.65. I have 200 kilonewton force acting here and the ordinate of that is 0.35. So I will write it as 100 into 0.65 plus 200 into 0.35. Okay, get me the value of RA.
135.
135.
135 kilonewtons. Any doubt with this? We started with the sum. There are 2 point loads, but at this point, this they have showed us or given us the question as this point as C. So what I'll do, I will draw that again. At that point C, I will apply a unit load. I'll call this distance as wherever we apply the unit load, that distance is x. The remaining distance will be 20 minus x. Take the moment at B, you will get the value of RA. Now the same procedure goes on repeat for RB, right? So I'll solve for RB. So when I'm doing for RB, the beam remains same. Itself is the beam, and this is your unit load acting at x, and this is 20 minus x. This all will remain same. This is RA and this is RB. Okay. Now, if I want to calculate RB, I will take summation MA equal to 0. I will take moment of all the forces about A equal to 0. So 1 into x, correct? 1 into x clockwise minus RB into 20, because this total entire thing is 20. So minus RB into 20 is equal to 0. From here, what is RB? RB is x divided by 20. Correct? RB value is going to be x divided by 20. So now I have to get x equal to 0, x equal to 7, x equal to 13 and x equal to 20, the values of RB. So 0 by 20, 0. Then 7 by 20, How much?
0.35.
Yeah, 0.35. 13 by 20, 0.65. And here it is going to be RB equal to 1. At x equal to 20, RB value is 1. So when I draw the influence line diagram for this now, RB became 1, right? And RA at point A it is 0. And here are your ordinates. So what is this? This is 0.65 and this is 0.35. Correct? Now I have to calculate the RB value. So how do I calculate RB? RB is calculated as the given load, external load, into the ordinate. Ordinate in ILD, influence line diagram. So ordinate now. For 1 second, you might feel you will get the same answers. Why? Because 0.65 and 0.35 are same. But you will get a different answer because their positions have changed and so the loadings will change. Right? So load is now 100 kilonewton into 0.35 plus 200 kilonewton into 0.65. 0.35 has got 100, 0.65 has got 200. So I multiply that. What is the value for RB?
165.
165.
165 kilonewton. RA you had got 135 and RB you got 165 kilonewton. Any doubt here? With respect to point C, you're getting the values of RA and RB. Any doubts?
No, ma'am.
Okay. Next, I have to go for shear force and bending moment now. Little it change, not change exactly, but there will be little change kinds. Okay. You have to use something called as the similar triangle rule. So now for calculating the shear force, right here, calculation for shear force, right? So when I'm calculating shear force, you remember when we had a single point load and when I start from the left side of the beam, always RA will go here as positive. But if I start from right side of the beam, based on your sign conventions, itara, plus minus. If I'm starting from left side, RA will always give me positive. And if I'm starting from right side, RB value is upward only always, but it will be going into negative. Correct? So based on that, we can always draw the shear force or it is something like this. Correct? Now with respect to this, I will have to get the ordinates at these levels and then calculate the shear force. Okay. Our actual beam is this 100 and 200 kilonewtons are acting at these 2 points. These 2 points. Okay. And then I have to now draw a diagram so that I will be calculating shear force with respect to what? Point C. So how do we draw that? Okay. So what you will do is I want to first calculate maximum negative shear force. Now, negative means which side is negative? RA is negative or RB is negative?
RB.
RB is negative. Meaning I will be looking for this diagram. Okay. So I will draw it once again. It is something like this. Your influence line diagram is something like this. This value you have got it as 1. Correct? You've got this value as 1. What you will do is I want it at point C. Correct? So I will take at 1 meter and I take one more section at X. Okay. Or look into this figure. This is 7, this is 6, and this is again 7. The distance between these two is always going to be equal to y. Okay. So from the figure, what is the value of y in our case?
6.
The value of y is going to be 6. So I will have to place the loading such that that y value will be maintained. That is 6. Okay. So if I draw this negative diagram like this, which is going down, I will have to take ordinates at these levels. Okay. I need these ordinates and I will name them here. I have to calculate the ordinates. Okay. So I'll call this as Z and I'll call this as Z1 ordinate. Right. At what distances? This would be 1 meters. Okay. And if this is 1 meter, this total is how much? 20 meters. right? And this is always 6 because in our given problem this is 6. So I will be looking for 1 meter from this end, right? Now use a similar triangle rule and get me the value of z1 and z. How you will get the value of z1 and z? 1 divided by z1 will be equal to 20 divided by this, or this by this will be equal to z1 by 1. You know this condition now? Are you aware of that? You have a triangle like this and you have similar triangle rule. Say you know this ordinate and you know the base, right? You call this y, you call this b. So y by b will be equal to this by this, or y by b is equal to this by this, right? Somebody is on unmute. Please mute yourself. Yaradu, mute yourselves, people. I have to use similar triangle rule. Similar triangle rule means this is apex, this is base. So distances from apex up to base, we can take ratios of that. I'll write it. I hope you will remember. 1 divided by z1. Now this is a triangle. I will be taking this triangle and the big triangle. So 1 divided by z1 will be equal to total base 20 divided by this side ordinate is 1. From here, what is the value of z1? Z1 becomes 1 by 20. And if I want to get the value of z, so this or z, you can either take this by this or you can take z by this, anyhow your choice. Okay. So this total is 7. 7 divided by z will be, 7 divided by z will be equal to total span divided by 1. Now, how many of you didn't understand this? Please tell me in the chat box. You can message. I don't mind. How many of you don't know how to apply similar triangle rule formula? Quickly. Understood what I did?
Yes, ma'am.
Right? So I want to calculate Z1 and Z values based on your 100 and 200 kilonewtons, okay, from the similar triangle at a distance 1 meter. This 1 is constant, this 6 is given in the question. So I will take that. From here, what is the value of Z?
0.35.
Z is 0.35.
7 by 20, ma'am.
7 by 20. You're getting 0.35. Correct. And what is 1 by 20? 0.05.
Point.
05, wala? So your Z1 value here is 0.05 and Z value is 0.35. I got the ordinates. Why I require the ordinates is when I calculate the maximum negative shear force now, I have to use the same formula, that is load into the ordinate, but ordinates I will substitute as negative because these are negative ordinates. Therefore, value maximum negative shear force value is going to be Z1 के साथ it is 100. So 100 into Z1. Z1 is minus 0.05, okay, plus load at this Z value is 200 and the ordinate of Z is minus 0.35. What is this value? Please, both are with negative signs. So you get a negative answer.
Minus 75.
You're getting minus 75 kilonewtons. Okay. Procedure, if I want to tell you in simple terms, you will not go ahead with the ordinates that you got first. You will have to plot another diagram of IID where you will, if especially for this case, when there are 2 point loads, distance between the 2 point loads is always going to be constant and it is given to us. So you will place these 2 point loads such that you will place it at 1 meters unit distance, 1 meters from the descent, the zero end. Okay, and then calculate the ordinates and calculate the shear value. Now this was negative. Same procedure I have to do positive. Okay, so it will be a bit clearer to you if we do once again positive. Now the same funda we will apply. Positive means the diagram is going to go like this, correct? And now I have to apply C point. My C point is here. So I will take C point at 1 meters and the other one would be at 6 meters. Y value is 6. Okay. So this I need the new ordinates at these 2 points. Okay, I'll call them as Z and Z1 only. What you had named them previously, Z and Z1, name it like that. Don't again reverse Z1 and Z. Z and Z1 only you name. We had placed it like this, or it was reverse previous case. I think this was Z, this was Z1 previous case. Now again find the value of Z1 and Z from this particular triangle, similar triangle rule. So how do we get, what is the remaining distance here? 1 and 6 means 7. This remaining distance would be 13. Correct? So get the values of Z1 and Z. It is going to be Z divided by 13 will be equal to 1 divided by 20. Z divided by 13 will be equal to 1 divided by entire span, 20. So Z value is going to be 13 by 20. 0.35. Correct, no?
0.65.
6.5.
0.65.
0.65. Next, again, I have to calculate Z1. Z1 divided by this distance now. What is this distance now? 13 plus 6, right? So Z1 divided by this distance is 13 plus 6 makes it 19, will be equal to 1 divided by 20. So what is the value of Z1? 19 divided by 20.
0.95.
0.95.
0.95. Okay. So these are your new Z and Z1 values. Therefore, when I'm calculating the shear force or maximum shear force, which is positive, I will use the same formula, that is 100 into Z1, okay, plus 200 into Z, right? So 100 into Z1 you got as 0.95 now, and 200 into Z value is 0.65. What is the value?
225.
25.
225 kilonewtons. So this is your maximum shear force, which is positive value. For that, I have to plot this diagram. So when we are plotting the diagram, remember when I was plotting the diagram, I want it at C point. So that C point will be placed at 1 meter. Here also now, this is my C point, so it is 1 meter. Distance between these two is constant, that is 6 meter. And then get the ordinates and multiply by, them by the external load that is given and calculate. Okay. So this is for your Z1 and Z. My Z1 and Z values are correct. Z is 0.65 and Z1 is 0.95. Correct. So this is about your shear force from ILD, and then remains this bending moment. So we'll quickly take bending moment. So when we are calculating the maximum bending moment, the maximum bending moment. So to go ahead for this maximum bending moment, what we will do, our actual loaded beam is like this. This is 100 and this is 200 kilonewton. What we will do, we will use your WAB by L with W equal to 1 and first draw the ILD diagram for that. So how is that possible? Your ILD diagram goes like this. For WAB by L I'm talking. I'm not talking of 2-point load system. So what is WAB by L? Right? So what you will substitute here? A value you will substitute 7, B value will be 13. Why 7 and 13? Because he has asked you for a point C. Always remember at what point they've asked. If the C was positioned here, your A value would be 7 plus 16, that is 13, and remaining 7. But they've asked us for point C. So this distance is A and remaining distance becomes B. So A becomes 7 and B becomes 13. So with W equal to 1, what is WAB by L? 1 into 7 into 13 divided by 20. How much is this value?
4.55.
So this is your
4.5.
4.55. WAB by L is for a single point load, no, which will have the diagram like this, right? I will call this as 4.55 as the ordinate. This is your point A and this is your point B. And with respect to this now 100, I have to get this ordinate in this influence line diagram. So I basically drew a ILD for a single point load using WAB by L. Once I draw that, based on our given beam now, I need to get this ordinate. Okay. And let us call this ordinate as Y. This is 4.55 we know. What is this distance and what is this distance? This We will take it as 1 meter, and 1 plus 6 would be 7 meters. Okay, because this is always going to be 6 distance between these two, right? Based on this, calculate from the triangle, similar triangle. 4.55 divided by 7, 4.55 divided by 7 will be equal to y divided by 1. So what is the value of y, please?
0.65.
You get 0.65 as the value of the y. And therefore, when I'm calculating the maximum bending moment with respect to C from the influence line diagram, I'll have to multiply these two ordinates with the loads. That is, for y, it is 100. So 100 kilonewton into 0.65 plus 200 kilonewtons into 4.55. What is the bending moment, please?
975 kilo.
975.
Kilonewton meter. Okay, so this ends the numerical. Little confusing. If we take 2-3 examples, you will be more clear. Right? Want me to explain briefly once again? I'll just stop the recording.